Hello and welcome to another one of D's ADD videos. We're going to go through an example of binomial distribution, but just to recap, we're looking at successive failures, whether we're talking about probability of getting an A, probability of winning a game or raffle, or whatever we're talking about. As long as you know the given probability of the event, then you can calculate out of a larger group what is the probability of the subgroup achieving that success. Average, variance, and standard deviation are listed right there. So let's look at example. So let's look at your stat class. Let's say the probability of getting an A in your stat class, we'll call that event A, is equal to 0.2. Alright? And let's say that there's 8 people in your study group, and you want to know what is the probability that one person gets an A. And then let's look at probability that at least one person gets an A. Actually, let's do 2 people get an A. And then let's look at finally the probability that at most 2 people get an A. Alright, so I'm going to do it first with the formulas and then with the tables, okay? So if I'm doing it with the formulas, the formula is n choose k, so n is 8, choose k is 1, and the probability was 0.2, and we said one person getting an A for this one right here, right? And 0.8 is 1 minus P, that's what Q is, and that's going to be raised to, you couldn't see that, I'm sorry, the 8 minus 1, which is 7. And when you plug into the factorial part of this, you get 8 factorial over 1 factorial, 8 minus 1 factorial, so that's 8 factorial over 7 factorial. Well, that becomes 8 times. We don't need to go any further than 7 because there's a 7 factorial right there on the bottom. So you can get 8 times 0.2 to the 1 is 0.2, and then 0.8 to the 7 raised to the 7 equals 0.2097, so we'll say 0.210. And when you multiply 8 times 0.2 times 0.210, you get a probability of 6. So what that tells you is the probability that one person out of your 8 people in your study group gets an A. Alright? So at least 2 people. So I'm going to write this in green because this is common to all discrete distributions. So the way you should look at that is you should first say at least. That means we start at 2 and get bigger. Alright? Now in this case, if you did that, you would need to do 2 plus 3 plus 4 all the way up to 8. And that's a lot of calculations. So it's easier to use the complement rule. So in the complement rule, we say 1 minus the probability of everything else. Well, that would be less than 2. Alright? So if that's less than 2, because these are discrete distributions, again, discrete means there's a probability for 1, there's a probability for 2, but nothing in between 2 and 1. So less than 2 is the same thing as saying 1 minus the probability of A is less than or equal to 1. Alright, so when we do the calculations, we really only have to do probability that A is equal to 0 and no, I'm sorry, it'd be an or, because this is all the situations in which we're less than or equal to 1, so it's 0 or it's a is equal to 1. Alright? So that's a very important concept for all the discrete distributions, whether we're talking about Poisson or binomial, geometric, whatever the scenario may be. So now back to plugging in numbers. If I got to do 0 and 1, let's do 0. So it would be, let's see, I can go up here to do it. It would be x equals 0 or a equals 0. It would be 8 choose 0 of 0.2 raised to the 0 people getting A, and 8 to all 8 people getting that. And that would be 8 factorial over 0 factorial, which this by definition is 1. And 8 minus 0 factorial is 8 factorial, so that cancels. And we know that anything to the 0 power is 1. So all we have is 0.8 to the 8th. Oops, didn't change math, that's okay. So let's see, 0.8 raised to the 8th equals 0.16777. So we'll say 0.168. So that was the probability of no people getting an A, given that there was 8 people in your study group, and the probability of 0.2 getting an A. And then if you do A equals 1, you have 8 choose 1, and that's going to be I'm sorry, 0.2 raised to the 1 person getting an A. I'm doing these all day today. I'm getting a little tired, it seems. So 8 choose 1. Whenever it's choose 1, it's usually going to give you the number 8 in this case, but I'll show it to you just to prove my point. So again, that whole 8 minus 1 factorial, 7 factorial, everything cancels just like it did over there. And you get just a prime of 8. And that would be times 0.2 times 0.8 to the 7th. So 0.8 to the 7th, oops, 0.8 to the 7th equals 0.210. I guess I did this calculation earlier, didn't I? Well, it's alright. 8 times 0.2, and I did all that earlier. I got 0.336. And if I take probability of A equals 0 plus probability of A equals 1, and have 0.168 plus 336, and then I'd have to do 1 minus that value. Sorry, my calculator's acting up. 0.336 gives me 0.504, and then that's gonna do 8.496. Alright, so that would be the answer for at least 2 people got an A. Alright, just recapping, what we did was we found A0, A is 1, add them together, and then did the complement following this logic in green here. Make sure you understand that logic, because if you don't, then you'll be in trouble. Alright, so then we look at most 2 people. So at most 2 people would be A is less than or equal to 2. Now the question here is it better to use a complement rule or just to calculate less than or equal to 2? Well, in this case, I would think that it'd be easier just to do probability of A equals 0 plus probability of A equals 1 plus probability of A equals 2, right? Instead of going 1 minus the alternative, which I don't want you to do, would be 1 minus the P of A equaling 3 all the way up to 8, which is like 6 calculations. So don't do that here. Ask yourself, don't just automatically go into complement mode when you see an inequality. So in this case, I've already done 0 and 1. It gave me 0.504 when I did these two values here. Alright, we did that a second ago, and I'll be somewhat awake and remember that I did that like before. So if I do 2, that would be 8 factorial over 2 factorial, 6 factorial, which that becomes 8 times 7 with the 6 factorials canceling. And 2 factorial is just 2, which that cancels, even 4 times 8, so the coefficients are 28. Times 0.2 raised to, we say, 2 people getting an A, and then that would be 0.8 raised to the 6 remaining people not getting an A. So we're going to do that in our handy dandy calculator. 0.8 raised to the 6 is 0.262, and then 0.2 squared is 0.04, and then when you multiply the 3, that's what you get. 28 times 0.04 times 0.262 equals 0.293. So that's just for 2, right? So we have to take that plus 0.504 to get the answer to the question we're looking for. And that gives us 0.797. So that would be at most 2. Alright? So that would be your binomial example using the formula. Make sure you check out the one for the table. It's a little different. Sometimes it's easier to use the table. It just depends. If you're asked for exact probabilities, just use a formula. Otherwise, it's probably easier to use the table. Alright? So that's basically it. Make sure you practice, practice, practice. Thank you and have a nice day.